So we're going to talk about the definition of trig functions, and the way that we're going to define them to begin with has to do with a point that's traveling around the origin. So let's come over here and let's look at this image. If I have the point P that has traveled, rotated, let's say, a value of theta, and it's stopped over here in the second quadrant, where it stops is defined as is given the location of xy, right? So if I have some point P over here in the second quadrant, the location of that point is given by xy. Now, if I drop a vertical line straight down to the x-axis, you can see that what I'm creating here is a perpendicular line, and therefore I've made a right triangle. Now, right triangles, and this right triangle, by the way, is defined by one leg being of value x, one leg being of value or length of y, and then we have our hypotenuse over here, which is defined as a value of r. And what's important about that is for us to remember that because I just created a right triangle, I can solve for any of these missing sides by knowing Pythagorean's theorem. Now remember, Pythagorean's theorem says the square of one side plus the square of the second side must be equal to the square of the hypotenuse. And so in trigonometry, we are dealing specifically with right triangles, and we use Pythagorean's theorem to be able to talk then about all sorts of values within our trig functions. Now over here in this gray box are the 6 trigonometric function values as defined by that point P that we saw traveling around the origin. So what we have here are the definitions. Now the definition of our trig function is that if I was to take the sine of that angle that we just rotated, it would be equal to the ratio of either the side or the hypotenuse, and it just depends on what we're looking at, but that's the idea. It's that relationship between the angle and the sides of my triangle. So for sine theta, and you need to memorize these 6 trig function values, and we'll be using them enough that that shouldn't be that hard, but we'll start off by talking about them. So here I've got the sine of theta. Sine of theta is defined as the ratio of side y divided by r. If we look over here, cosine of theta is defined as side x divided by the hypotenuse of r. And tangent of theta is defined as side y divided by side x. Now, sine, cosine, and tangent are the 3 most common ones that we see. Those are the ones that if you were to look at your graphing calculator, you would see those are the terms that actually show up on your calculator. But what about this second row down here? This second row says cosecant, secant, and cotangent. Now the cosecant of theta is defined as r over y, secant theta is defined as r over x, and cotangent is defined as x over y. If you notice though, notice the row right above what we were just looking at. Sine theta and cosecant theta are both related in that sine and cosecant are just flipped from each other, right? They're reciprocals of each other. So where the sine of theta is equal to y over r, cosecant of theta is simply the reciprocal of that ratio, r over y. We have a similar relationship when we want to talk about cosine and secant. Cosine's x over r, and yet secant is r over x. And finally, we have the same type of relationship down here with tangent and cotangent, in that tangent and cotangent are reciprocals of each other. So right away, this is going to help us, if you have to memorize sine, cosine, and tangent, that those definitions that you see listed there, and you just need to start recognizing that for every function value that you're seeing on sine, cosine, and tangent, there is a reciprocal value with their related functions of cosecant, secant, and cotangent. So the way that I always think about this, the way that I learned it when I was first learning this, was sine and cosecant go together. And I know that because sine and cosecant cannot start with the same letter. So sine and cosecant can't have the same letter. And that way I don't get confused, because if I was looking for cosine and secant, they can't start with the same letter. So that's how I remembered it. And then I've always been able to I get cotangent and tangent. So those are the 6 trig function values that you're going to be responsible for memorizing. And now let's put them to some use by looking at this example down here. So the first example we're going to look at tells us that we have some point 815, and it is on the terminal side of some value theta, and I want to know what are the 6 trig function values that pass through that given point. Now most of the time when we're in trig, we want to start by drawing a graph or some sort of image so that I can get an idea of what I'm looking at here. And it doesn't have to be perfect, we just kind of want a rough sketch. So if I were to plot the point 815, I know that it's going to occur somewhere over here in the first quadrant. So what I have is a value, right, coming from the origin straight out to that point, and I know that if that point were rotating, it would have rotated some value of theta. Now, to go back and start using our definition of trig functions, I want to start by drawing a right triangle off of that point. So I'm going to drop a vertical perpendicular line down here to the x-axis, and I'm able to then identify one of the legs of my right triangle along the x-axis has to have a length of 8. One of the legs on the y-axis, or moving in a distance of y, has to have a leg of 15, and now I just need to solve for r. So if I were to summarize that, I know that x is equal to 8, y is equal to 15, and I need to figure out what is r. Now some of you may or may not already be recognizing that this is indeed a special triple triangle, but if you don't recognize that, how am I going to find r? Well, if you notice up here in our definitions, r is defined as, or r is equal to the square root of x squared plus y squared. But where does that come from? Well, remember we said that our triangle is based on Pythagorean's theorem. Because we have a right triangle, we can solve for any of the missing sides. So if I were to say x squared plus y squared is equal to r squared, and solve that equation for r, I would just need to then take the square root of both sides, and I would find that r is equal to the square root of x squared plus y squared. So coming down here, let's see, that's what we're missing. I need to know what r is. So I'm going to take the square root of x squared plus y squared, which is the square root of 8 squared plus 15 squared, and if I put that into my calculator, I'm going to find out that that is 17. So a right triangle of legs 8, 15, and 17 is a special right triangle. Now what do I do with that? Well, now I want to use the definitions from this gray box up here, and I want to write out what the 6 trig function values are for theta. So I'm going to start by taking the sine of theta, which is defined up above as the ratio of y over r. So that's going to end up being y is 15 and r is 17. So the sine of theta is equal to 15 over 17. How about cosine? Cosine of theta is defined as x over r. Therefore, x is 8, r is 17, so it's the ratio 8 over 17. And then I just keep going in order. I'll come back up there. Tangent is defined as, the tangent of theta is defined as y over x. Y is 15, x is 8. So now I have all 3 function values for the top row of sine, cosine, and tangent. I typically will work in this order so that when I need to go through now and figure out the remaining 3 function values, cosecant, secant, and cotangent, I can look at what I've already gotten written because remember, they're just reciprocals of each other. So here I've got cosecant of theta, which is defined as r over y, so that would be 17 over 15. Secant theta is defined as r over x, or 17 over 8, and cotangent of theta is defined as x over y, or 8 over 15. So that's how we find out what those 6 trig function values are for a given point, 8, 15. Now let's do a similar problem, only this time, instead of problem A, let's look at all 6 of those trig function values for the point -3, -4. So again, I'm going to start by plotting the point -3, -4. Now it would be down here in the third quadrant, somewhere around here. And if I'm talking about the angle theta that is rotating around and stopping at this spot, I can create now a right triangle that has one leg of -3, one leg as -4, and again I'm going to have to figure out what r is. So let's summarize that. X is equal to -3, y is equal to -4, and r is equal to the square root of -3 squared plus -4 squared, or +5, because this is a 3, 4, 5 triangle. So when I come in here and I write the 6 trig function values, starting with the sine of theta, remember sine of theta is defined as y over r, so that would be -4/5. Cosine of theta, just looking at our definitions up there, would be x over r, or -3/5. And tangent of theta is defined as y over x, or 4/3, because -4 over -3 is a +4/3. Now let's come back in and we're going to do cosecant. Cosecant is the reciprocal of sine, so it would be r over y, or -5/4. Secant of theta is defined as r over x, or -5/3. And cotangent of theta is defined as x over y, or +3/4. So just taking what we've learned about the 6 definitions, or the definitions of our 6 trig functions, we can figure out what those function values are based on the ordered pair of a point and the definitions of our function values.